Hey folks, Marco here. Welcome back to topic 2 of our course on Stable Diffusion and Artificial Intelligence. The main topics today are AI models, the most important platforms you should be aware of, and a very brief intro to Stable Diffusion architecture. If you recall, we said that Stable Diffusion at its heart has convolutional neural network that has learned how to remove Gaussian noise from the image. We have called such process denoising, analogous to milk diffusing in tea, although playing in reverse. We spoke about the stochastic nature of the underlying process. We have drawn parallels with thermodynamic concepts of temperature and entropy, which have machine learning analogs. When you saw what my house looks like, you understood that convergence towards the state of maximum chaos is one of the most fundamental natural laws. As English astrophysicist Sir Arthur Eddington put it, your theory disagrees with electrodynamics? It's okay, just blame it on the Irish. Disproven by experiments? They really need to stop using grad students as cheap labor, lab coat wearing motherfucker. But if your crackpot theory offends the second law of thermodynamics, man, you are royally. Okay, I confess I may have paraphrased them a little bit. Here's the actual quote. Point is, what engineers and scientists have done with this technology is truly amazing. To see image form right before our eyes is as miraculous as seeing me cleaning my house. Of course, like all analogies, analogy with thermodynamics has its limits and we can only push it so far. For example, whereas the natural diffusion is continuous, stable diffusion adds and removes noise iteratively. We defined these iterations as steps, and we call this workflow text-to-image. We have also discussed the workflow where we take partially noised image and denoise it. By guiding the diffusion using both image and text, we can make a variation to the image. Instead of a male samurai, I have female samurai, all the while maintaining image style and composition. This is how image-to-image workflow works conceptually. Practically, however, we don't do things this way. If we did, each time you ran text-to-image, you would have to store each iteration of every step you create just in case you decide one day to run image to image. No, what we do instead is we use clean image and specify how much noise to add. The more noise you add, the stronger the denoising required to get us back. Unsurprisingly, the strength of denoising is quantified by a parameter called denoise strength. This is where you specify how deep into chaos you're willing to descend. 0% meaning no chaos and 100% maximum chaos, and we call this image to image. Today I want to discuss diffusion models and platforms. Installing Stable Diffusion is the easy part. Plenty of YouTubers have shown you how to do that. This video will hopefully prepare you for the terminology you encounter inside your web UI and possibly on platforms where you go to download the checkpoints. I want to begin with platforms first. There are two main platforms you should be aware of. Civitai is a community-driven hub with focus on AI art generation. This is the primary place of sharing custom fine-tuned models, although these days it also has an on-site generator, training, educational resources, and so on. Hugging Face is a platform where machine learning community collaborates on models, datasets, and applications. This one is not specific to art, and it is more geared towards general machine learning applications, including sound, datasets, pipelines, research, and many educational resources on various ML subjects. Think of it as GitHub of the machine learning world. If this is all completely new to you, go create a Civitai account and just download a checkpoint from there. But wait, what a checkpoint? If you're confronted with something like this for the first time, all this jargon can be somewhat intimidating. Let me quickly bring you up to speed. The rest of you just please bear with me. I promise I won't ramble for too long. Firstly, let me simplify this image. If I exclude models that are distilled, made by community, models that don't generate images, text to video, text to speech, and so on, this is what remains. These are called foundation models. 1.4, 1.5, 2.0, 2.1, version 3, and STXL. And before you ask, no, you did not miss out on Stable Diffusion 1.0 and 1.1 and 1.2. If you need some clarification, basically, the short version is that they started with 1.1, which they trained further to 1.2, and all the remaining versions are essentially the continuation of 1.2 training. You can read the exact parameters used on Runway ML GitHub repository. So Stable Diffusion 1.4 came out in August 2022, and 1.5 came out a couple of months later. Both models were trained on square images of 512 pixels, and that is the resolution they can generate. Oh gosh, if you hear any snoring, this is just my dog in the back, curled up. Both these models, the denoising process is implemented in a way that greatly reduces computational requirements, as we will see in a moment. The following month, November 2022, version 2.0 comes out. Coincidentally, that is the same month when Civitai platform first started. Stability AI, company behind Stable Diffusion, implemented significant changes, both in terms of model architecture and training dataset. This model was trained on 768 pixel square images. For whatever reason, this version was not well received by the community, even after the 2.1 update, which came out on December that same year. Look, between these four models, I don't think it's controversial to say that version 1.5 is the most popular, the most supported, and I would argue the most loved foundation model. I'm certain that even users who have since moved on to other foundation models still think fondly of 1.5. Jesus Christ, Chloe. Sorry, that's my dog sleeping in the back. 1 year later, July 2023, version STXL comes out. And this is the second most popular model from the list. This model was trained on 1024 pixel square images, so double the size of SD 1.5. Let me briefly add that if you see a filter that says SDXL 0.9, that's referring to fine-tunes that are based on leaked version of SDXL. Look, feel free to look it up. I can't tell you more because honestly, I don't follow that corporate politics drama all that closely, but just thought it's important to tell you just in case you see it and think, oh, what's this 0.9 about? And lastly, Stable Diffusion 3, strictly speaking, SD3 is not a foundation model, it is a family of models. They were released in February 2024 via API. As of this recording, they have yet to be fully released for local inference. Lastly, I just want to briefly talk about Stable Diffusion architecture. You see, so far I have not really provided any answers. How can my written word bring order out of chaos? That's some Thanos level shit going on here. So to get to the bottom of this, we need to see what hides under the hood. In 2022, a team from CompVis Research Group, LMU in Germany, in collaboration with Runway ML, published this paper, High Resolution Image Synthesis with Latent Diffusion Models. On page 4 of that paper, you will find this schematic, which shows us Stable Diffusion inner workings. Now, I don't know you. I don't know your background. Maybe this paper is from your field and you know more about this schematic than me. Equally likely, perhaps you could be someone who has lived a difficult life, did not graduate from high school, and is freaking out with all these equations and maths. What I hope to do with this channel is to make this accessible, so no one looks at something like this and thinks that for 1 minute that this is beyond their ability to understand. So in the next 45 seconds, I'm going to summarize to you what you already know about this graph. So I'm going to use that same samurai example from before. You already know what diffusion process is. Forward diffusion introduces Gaussian noise. You also know what conditioning is. You know that conditioning can be done using text, but you also know that you can use image as well. That's what these two labels mean. Now, what is the purpose of conditioning? You know that too. It guides the denoising process. It is how we control what emerges from the chaos. And that is how we get the output. See? Easy. Now let's build on from here. You see, denoising mechanism inside Stable Diffusion does not operate on pixels. In fact, that is the essence of this paper. Denoising process is happening in latent space. So by encoding image into a lower dimensional space, computational requirements have been significantly reduced, and this is what made it possible to run Stable Diffusion on common consumer hardware. See these letters, E and D, that were on the diagram earlier, written in cursive script, they represent encoder and decoder. Pixel image gets encoded into a latent image, which gets decoded back into a pixel image once the processing is done. And so we have Variational Autoencoder, or VAE, which performs these tasks. I also have clip, which inside contains tokenizer and handles the encoding of text. And we can probably end the lecture here. Just briefly, I do want to thank my very first Patreon supporter. During the times of economic turmoil, of cost of living crisis, rising inflation, or deflation if you're in China, someone threw in support for this channel, knowing that there is nothing that I'm hiding behind the Patreon paywall. You know who you are. All I can say is thank you. I nearly forgot that I had these portals on, to be honest. When I got notification, I was going over all this literature. I was trying to understand how variational autoencoders work precisely. How can there be a low-dimensional data manifold and a manifold hypothesis, Markov chains, all this sort of stuff. So yeah, I was quite going down rabbit holes here. Anyway, where do we go from here? So you can leave a comment, let me know what you're interested in. I know Flux is very popular at the moment, but I feel that there are things that we are not really talking about or people aren't discussing much. So I thought I would perhaps cover things that other YouTubers may not be doing. But whatever you want to do, just let me know.